So friends, let us start the topic conic section, and the first topic on the conic section is parabola. Okay. Now, before going to detail in parabola, we'll understand that how to recognize a conic from any second degree curve of x and y. Okay. So first of all, you just write the heading recognitions of conics from any second degree curve. Okay. So please write down recognition of conics. Okay. Now just consider any second degree curve of x and y. So let the equation of x and y, this is second degree curve. Okay. The equation is ax square plus by square plus twice hxy plus twice gx plus twice fy plus of c is equal to 0. Now to recognize this equation, whether it is represents a parabola or ellipse or hyperbola, we have to go through few tests. Now what are these tests? Okay. So if delta is a value which is equal to a into b into c plus 2 into f into z into s minus af square minus bg square minus ca square, and if this value is not equal to 0, okay, then this equation 1 represents any conic. Okay. So it is necessary that this equation ax square plus by square plus 2hxy plus 2zx plus 2fy plus c is equal to 0 represents a conic. The value of delta should not be 0. That is, the value of a into b into c plus 2 into f into z into h minus a into f square minus b into g square minus c into a square should not be 0. Okay, clear? Now, how to recognize that this equation 1 or this equation of conic represents a parabola or represents an ellipse or represents a hyperbola? Okay, so look, we need to further find out a value which is equal to a square minus ab for this purpose. So if delta is not equal to 0 and the value of a square minus ab is equal to 0, a square minus ab may be positive, may be negative, may be 0. So if a square minus ab is 0 and delta is not equal to 0, then this equation 1 represents a parabola. Okay, represents a parabola. Is it clear to you? Okay, now come to another concept. If the value of delta is not equal to 0 and the value a square minus ab is less than 0, okay, then this equation 1 represents an ellipse. Then equation 1 represents an ellipse. Okay, clear? Now, and if the value of a square minus ab become positive such that delta is not equal to 0, then this equation 1 represents a hyperbola. Okay, so if delta is not equal to 0 and the value a square minus ab is positive, that is greater than 0, then equation 1 represent a hyperbola. Okay. Now you know there is a specific type of hyperbola is known as rectangular hyperbola, which is also a hyperbola. So to recognize the rectangular hyperbola, that is to recognize whether this given equation 1 is a rectangular hyperbola or not, we need an additional test, that is whether the value of a plus b is equal to 0 or not. Okay. So if delta is not equal to 0 and the value a square minus ab greater than 0, this is the condition for that a conic become hyperbola. Rectangular hyperbola is also a hyperbola, that's why these two conditions are required. The additional condition is the value of a plus b is equal to 0, that is the sum of coefficient of x square and y square is equal to 0. Then equation 1 represents a rectangular hyperbola. Understand? Clear? So then equation 1 represents a rectangular hyperbola. You understand what I say? Clear? Okay. So what we learn? Any second degree equation of x and y can represent a conic under the conditions that the value of delta is not equal to 0, where delta is equal to abc plus 2fgas minus f square minus bg square minus ca square. Now when delta is not equal to 0, then this equation 1 may be parabola, ellipse, hyperbola or rectangular hyperbola. Now to recognize this specific conic, we have to find the value of a square minus ab. If delta is not equal to 0 and a square minus ab is equal to 0, then the equation 1, that is this second degree equation of x and y, represents a parabola. If delta is not equal to 0 and a square minus ab is less than 0, then this equation 1 represents an ellipse. If delta is not equal to 0 and a square minus ab is greater than 0, then this equation 1 represents a hyperbola. And to recognize the rectangular hyperbola, delta should not be equal to 0. The value of a square minus ab is greater than 0. Additionally, we have to test the value of a plus b, and if a plus b becomes 0, then we become sure that this equation 1 represents a rectangular hyperbola. Understand? Clear? Okay. Now come to the detailed concept on parabola. So let's start the concept on parabola. Okay, let's have a look. So friends, let us start the definition of parabola. Okay, so we'll start the topic parabola, and first of all we'll discuss what is parabola, that is what is the definition of parabola. Okay, so please write down definition of parabola. Very important to understand the characteristics of parabola, okay, or different properties of parabola. So parabola is the locus of a variable point whose distance from a fixed line and from a fixed point is always equal. Okay, and this fixed line is known as directrix of the parabola and the fixed point is known as focus of the parabola. Clear? So please write down the definition. A parabola is the locus of a variable point. So say the variable point is p, which is x comma y. We know we normally give or normally represents any variable point in coordinate geometry as x comma y. So p is a variable point and its locus will be called a parabola if its distance from a fixed line, say the fixed line is ax plus by plus c is equal to 0, and from a fixed point, say the fixed point is S, which is alpha comma beta. So fixed point means the stationary point. Fixed line means the stationary line. Okay. So parabola is the locus of a variable point px comma y if its distance from a fixed line ax plus by plus c is equal to 0 and from a fixed point S, which is alpha comma beta, is equal. Okay. Is equal. Clear? Understand? So let us draw the diagram, then it will be more easier to you. So suppose this is a fixed line and equation of this line is ax plus by plus c is equal to 0. And just think this is the parabola. Okay, clear? Now, just think this is any stationary point whose coordinate is alpha comma beta. Clear? Now, parabola is the locus of any variable point. So, you see, P is x comma y is any variable point whose distance from this fixed line, that is, you know very well that distance of any point from the any line is basically its perpendicular distance. So Pn is the distance of this point x comma y from the fixed line ax plus by plus c is equal to 0, and from the stationary point the distance of P is Ps. Okay. So if Pn is equal to Ps, then locus of this point P will be this parabola. In other sense, or alternatively we can say, from any point on the parabola, the distance of a fixed line and the fixed point are always equal. Okay. This fixed point is known as focus. This is the focus, and this fixed line is known as directrix. This is known as directrix. Okay, so this is the directrix of the parabola and this is the focus of the parabola. Get it? Clear? So the condition is, you can write Pn is equal to Ps. Okay, clear? So if Pn is equal to Ps, then locus of P, that is x comma y, is a parabola. Okay, clear? Please write this additional statement. The fixed line is known as directrix of the parabola, and the fixed point, which is S, okay, is known as focus of the parabola. Okay, clear? So what we learned? We learned that parabola is nothing but the locus of a variable point. The variable point is Px comma y from a fixed line ax plus by plus c is equal to 0, and from a fixed point, that is S, which is alpha comma beta, is equal. And this fixed line is known as the directrix of the parabola, and the fixed point is known as the focus of the parabola. Okay. So in this given diagram, the equation of this fixed line is ax plus by plus c is equal to 0. Px comma y is any variable point and s alpha comma beta is any stationary point. Okay. Now if Pn is equal to Ps, then locus of this point P is nothing but a parabola. Okay, clear? Understand? Now come to the detail in the parabola. Now we will come for some standard form of the equation of the parabola, okay, which are in your syllabus. Let's have a look. So friends, let's start the standard forms on parabola. Okay, so the first form is y square is equal to 4 into a into x. So parabola is of the form of y square is equal to 4 into a into x. This type of parabola is concave at right hand side and the vertex of the parabola is at the origin and the axis of the parabola is the positive direction of x-axis. Okay, so please look the figure. So this is the parabola whose equation is y square is equal to 4 into a into x. So the parabola is concave at right hand side and the vertex of the parabola is at the origin. Okay, and the axis of the parabola is the positive direction of x-axis. Okay, you know very well axis is nothing but a line which symmetrically divides the curve. So this is the x-axis which symmetrically divides the parabola. So that is why the positive direction of x-axis is known as the axis of this parabola. Okay, clear? So in this case, number 1, vertex of the parabola is origin. Okay, so origin is 0, 0. So vertex is at origin. Clear? Axis of the parabola is positive direction of x-axis. So this is the axis of the parabola. Okay, whose equation is nothing but y is equal to 0. So you just write axis of the parabola is y is equal to 0. Got it? Clear? Now where the vertex is at origin and axis is at axis is the positive direction of x-axis. The equation of axis is obviously y is equal to 0. Now this is the interior region of the parabola and this is the exterior region of the parabola. So this is the interior region of the parabola. You just write interior region. Okay. Now at the interior region, on the axis of the parabola, there is a fixed point which is known as the focus of the parabola. Okay. So this is the point is lies on the axis of the parabola and inside the parabola or at the interior region of the parabola. This stationary point, you know, is known as the focus of the parabola. Okay. Now, distance of this focus from the vertex is equal to a. Okay. So, in the equation of parabola y square is equal to 4 into a into x, this a represents the distance of the focus from the vertex. Okay, clear? So, please write down number 3, a equal to distance of the focus from the vertex. Okay, clear? And the focus lies on the axis. So you please write focus is, what will the coordinate of the focus is? If the distance of this focus from the vertex is a and focus lies on the axis of the parabola, here axis of the parabola is x-axis, so that is why the coordinate of the focus will be a comma 0. Okay, clear? So write down focus is, whose coordinate is a comma 0, okay, lies inside the parabola. Okay, clear? Now come to the concept of directrix. Directrix of this parabola is perpendicular to the axis of the parabola and lies outside of this parabola at a distance a unit from the vertex. So, let this is a point on the axis of the parabola and this point lies at the exterior region of the parabola. Distance of this point, suppose this point is D, distance of this point D is at a unit from the vertex. Okay, clear? Got it? Now, directrix is perpendicular to the axis of the parabola. So, this will be the directrix. Okay? So, what we learned? Directrix of the parabola y square is equal to 4ax lies outside of the parabola and directrix is perpendicular to the axis of the parabola and vertex is the midpoint of directrix and focus. Got it? Clear? So, this is the directrix. And what's its equation? As directrix of this parabola y square is equal to 4ax is nothing but parallel to y-axis. So that is why its equation will be x is equal to minus a, because the point D has coordinate minus a comma 0. Got it? So that is why the equation of this directrix will be x is equal to minus a. Clear? We know equation of any line parallel to y-axis and passing through the point minus a comma 0 must have equation x is equal to minus a. Okay, clear? So please write down directrix is x is equal to minus a. Clear? What we learned? We learned vertex is the midpoint of the directrix and the focus. Okay? So vertex is the midpoint of directrix and the focus. Clear? And directrix is always perpendicular to the axis of the parabola. Okay, so and directrix is always perpendicular to the axis. Okay, so direct is always perpendicular to the axis. So I think you understand about the structure of y square is equal to 4x. You understand about the focus of the parabola y square is equal to 4x and understand about the vertex, axis and directrix. Okay, now look, if P is any point on this parabola, definitely the distance of this point P from the focus, that is PS, and distance of this point P from the directrix, that is Pn, are equal. Okay, clear? So you should write Pn is equal to Ps. Okay, clear? Look, now we'll go for another concept, that is focal chord and the least focal chord, which is known as the lattice rectum. Okay, so look, any chord passing through the focus of the parabola are known as focal chord, and the least focal chord is known as the directrix of the parabola. So if I draw here a chord passing through focus, look, this is AB is a chord which is a focal chord. Got it? So AB is a focal chord. Any chord AB passing through the focus is known as focal chord. Okay. So for any conic, for hyperbola, ellipse or parabola, any chord passing through the focus of that conic are known as focal chord of that specific conic. So here this chord AB passing through the focus of this parabola, so this is known as focal chord of this parabola. So there are infinite number of focal chord, and the least focal chord which will be the perpendicular to the axis of the parabola. Is it? So I am drawing here the least focal chord. Just look. So here L1, L2 is the least focal chord. Sure? Least focal chord means its length is minimum. Clear? Among all focal chord. This focal chord, this least focal chord is known as lattice rectum of the parabola. Okay? So write down please. Least focal chord is the lattice rectum in the diagram. It is L1, L2. Okay, L1, L2 whose length is basically equal to 4a. So what is the length of the lattice rectum of the parabola y square is equal to 4x? Its length is equal to 4a. So least focal chord is the lattice rectum of the parabola. Got it? Clear? So this length is equal to 4a. So this L1 S has length 2a and this SL2 has also length 2a. So L1 L2 must be is equal to 4a. Got it? Clear? Understand? I think all of you understand about the concept of the parabola y square is equal to 4x. Okay, so what we learn about the constructions of y square is equal to 4x? Y square is equal to 4x is a parabola which is concave at the right hand side. Its vertex is at origins and the axis, that is the line which symmetrically divides the curve, is the x-axis here. So equation of the axis of the parabola is y is equal to 0. This side is the interior region and this side is the exterior region. Focus is a fixed point on the axis of the parabola at a distance a unit from the vertex. A is in the equation y square is equal to 4ax. Okay, so the coordinate of the focus will be a comma 0. Directrix is a fixed line which have a distance a unit from the vertex and directrix is perpendicular to the axis of the parabola. Got it? Clear? If any point P x comma y is on the parabola, then the distance of this point P from the directrix is Pn and distance of this P from the focus is Ps. According to the definition of the parabola, this Pn should be is equal to Ps. Okay, clear? And any chord passing through the focus are known as focal chord and the least focal chord is known as latus rectum of the parabola. In the given diagram L1, L2, which is perpendicular to the axis of the parabola, this is the least focal chord and this least focal chord, that is the latus rectum, has length 4 into a. 4a present already in the equation y square is equal to 4ax. Okay, clear? Understand? Now if we want to find out the ends of the latus rectum, so what is the coordinate of L1? Coordinate of L1 will be definitely a comma 2a. Okay, what is the coordinate of L2? The coordinate of L2 will be a comma minus 2a. Okay, understand? So in this way you have to remember all the data for numericals. Okay, now come to the another form of the parabola, that is y square is equal to minus 4ax. Okay, so let's have a look. So friends, now we are discussing the another form of the parabola, that is y square is equal to minus 4ax. The parabola y square is equal to minus 4ax is concave at the left hand side and its axis is negative direction of x-axis but vertex is at origin. Okay, so look, I am drawing the diagram. So considering this is the parabola which is concave is at the left hand side. Okay, and we all know that axis of the parabola is the line which symmetrically divide the curve. So definitely this is the line which I draw the x-axis symmetrically divide the curve. So this line is nothing but the axis of the parabola. Okay, and consider the vertex is at the origin. So this should be the tangent at the vertex, okay, which is nothing but y-axis. Clear? Understand? So what is the equation of this parabola? The equation of this parabola is y square is equal to minus 4 into a into x. So vertex is at the origins. So in this case also we will write number 1, vertex is 0 comma 0. Okay, the axis is the negative x-axis. So definitely axis of the parabola here has equation again y is equal to 0. Okay. So please write down axis is y is equal to 0. Both positive direction of x-axis and negative direction of x-axis has same equation, y is equal to 0. So this is the interior region in this case, and this will be the exterior region. Sure, exterior region. Okay. Now come to the directrix of the parabola. Definitely, as we already learned, that directrix lies at the outside of the parabola. So considering this is the directrix, okay, and directrix is perpendicular to the axis. So this is perpendicular to the axis, okay. And you know very well the distance of the directrix from the vertex is equal to A. Okay, clear? So what is this point? This point has coordinate A comma 0. That is the intersection of axis and directrix has coordinate A comma 0. So what is the equation of the directrix? It should be x is equal to A. So directrix has equation x is equal to A here. Okay, so you please write directrix is x is equal to A. Okay, now we all know the focus of the parabola lies at the interior region of the parabola. Okay, and distance of the focus from the vertex is again A, and focus lies on the axis of the parabola. So that is why we can consider that this is the point which is focus of the parabola, and the distance of this focus from the vertex is A. Okay, clear? So what is the coordinate of the focus? The coordinate of the focus will be here minus A comma 0. As this focus lies on the x-axis, so y coordinate will be 0, and as S lies on the negative x-axis, so x coordinate will be minus A. Okay, so please write the focus S is minus A comma 0. Okay, clear? That is why we can say the vertex is the midpoint of focus and the point D, where D is nothing but the intersection of axis and the directrix. Okay, clear? Definitely this should be our latus rectum, which is the least focal chord and perpendicular to the axis. Okay, so this is the latus rectum L1, L2, and latus rectum has length is equal to 4 into A. So in the equation y square is equal to minus 4ax, the latus rectum has length 4 into A. So you can say this is 2a and this length is also equal to 2a. Okay, clear? So you should write L1, L2 is equal to 4a equal to length of the latus rectum. Okay? Understand? We already discussed that latus rectum is nothing but least focal chord, and latus rectum is perpendicular to the axis of the parabola. Okay, clear? Now, as per definition, if P is any variable point on this parabola, then PS should be is equal to Pn. Okay, where Pn is the distance of the point P from the directrix and PS is the distance of the point P from the focus. So this is very important point, and you can say the most important point in the study of parabola. So PS is equal to Pn, where P is any variable point on the parabola. Understand? Clear? Now come to the another concept on parabola, that is x square is equal to 4ay form. Okay, so let's have a look. So friends, now we are discussing the equation of parabola is of the form of x square is equal to 4 into a into y. Okay, so look, what is the form of this type of equations? So let's first draw the figure. Okay, so the parabola x square is equal to 4ay is concave upward and its vertex is at origin. So this is the parabola whose equation is x square is equal to 4 into a into y. Okay, and this is the line which is y-axis symmetrically divide the curve. So hence y-axis is the axis of the parabola here and vertex is at origins. Hence if we draw the tangent at the vertex, this is x-axis. Okay, clear? So vertex is at origin. Is it clear? So just you write vertex is at origin here also and axis is positive direction of y-axis, and you know very well the axis has equation here x is equal to 0. Okay, so axis is x is equal to 0. Okay, clear? Now distance of the focus from the vertex is here again a unit and focus lies at the interior regions of the parabola. So this is the interior region and this is the exterior region. Okay, this is the exterior region. Okay, so inside the interior region and on the axis of the parabola there is a stationary point. So this is the stationary point which is S, and S has a distance from the vertex a unit. This S is the focus and coordinate of this focus obviously will be 0 comma a. Okay, clear? So what is the coordinate of the focus? So focus is S, which is 0 comma a. Clear? Okay, definitely this is the latus rectum, the least focal chord. So L1 L2 is the latus rectum. Okay, and you know very well latus rectum of any parabola has length 4 into a. Okay, so this is 2a and this is also 2a. Clear? Okay, so L1 L2 is equal to 4a equal to length of the latus rectum. Now what is directrix? Directrix lies outside of the parabola, that is at the exterior regions of the parabola, and it is perpendicular to the axis. So we can consider that this is the directrix. Okay, and directrix has also distance a unit from the vertex. Okay, and directrix is perpendicular to the axis of the parabola. Clear? So what is the coordinate of this point D? That is the intersection of directrix and axis. Definitely this is 0 comma minus a. Okay, so what is the equation of this directrix? So its equation should be y is equal to minus a. Clear? Okay, as directrix is parallel to the x-axis and passing through the point 0 comma minus a, so equation of directrix will be y is equal to minus a. So you should write directrix is y is equal to minus a. Understand? Clear? Now if we consider any point on the parabola which is P, the coordinate is x comma y as it is a moving point. So its distance from the focus, that is PS, should be is equal to distance from the directrix, that is Pn. So that is why here also we should write PS is equal to Pn. So I think you understand about this parabola. Okay. So when the parabola is x square is equal to 4ay, then parabola has vertex is at origin. Okay, clear? When the parabola is x square is equal to 4ay, then its directrix is y is equal to minus a. The focus is at 0 comma a and length of the lattice rectum is here 4a. And if p is any variable point on the parabola, then ps is equal to pn according to the definition of the parabola. Understand? Clear? Understand or not? I think it is clear to you. Okay, now let's come to the another form of the parabola, that is x square is equal to minus 4ay. Okay, so let's have a look. So friends, now we are discussing parabola is of the form of x square is equal to minus 4ay. The parabola x square is equal to minus 4ay is concave downwards and its vertex again at the origin. Okay, and axis is same, that is y axis. So let's draw the diagram first. So this is a parabola which concave downwards. Equation of the parabola is equal to x square is equal to minus 4ay. Okay, clear? So this is the line which is y axis symmetrically divide the curve, hence this is the equation of the axis. So axis of the parabola is the y axis, you can say the negative y axis, and its equation is x is equal to 0. So we should write axis is x is equal to 0. Okay, clear? Now what is the vertex? Vertex is at origin. Definitely this is the x-axis and origin is the vertex. So we should write vertex is at origin 0 comma 0. Now definitely this will be the focus which is at a distance a unit, and the coordinate of the focus will be 0 comma minus a. Okay, so we should write the focus is S, which is 0 comma minus a, and the length of the lattice rectum is L1 L2, the least focal chord, is it? So we write here L1 L2 which is perpendicular to the axis. This is the lattice rectum, and length of the lattice rectum again 4a, that is these values are 2a and 2a. So length of semi-lattice rectum are 2a. So please write L1 L2 is equal to 4a equal to length of the lattice rectum. Okay. Now come for the directrix. So directrix is perpendicular to the axis of the parabola. So this will be the directrix. Okay, this is the point D, and D has distance from the vertex equal to a. Okay, so the coordinate of the D will be definitely 0 comma a. So this directrix has equation y is equal to a. Okay, clear? So what is the directrix? Directrix has equation y is equal to a. Understand? Clear? Now if we consider any point P on this parabola, suppose P which is x comma y. Now distance of P from focus is PS, and distance from P from this directrix is Pn. Okay, and PS should be is equal to Pn. Understand? Clear? So this is the whole diagram for x square is equal to minus 4ay from parabola. Understand? I think it is clear. All of these four forms belongs to your syllabus and very important for your numericals. So please remember these forms. Now come to another form of the parabola. Okay, where the parabola have vertex at alpha comma beta. So let's have a look. So friends, now we are discussing the parabola is of the form of y minus beta whole square is equal to 4a into x minus alpha. So in this case, the parabola has vertex at alpha comma beta. So this alpha and beta represents the coordinate of the vertex of the parabola. And the parabola is concave at right hand side. The axis of the parabola is parallel to x-axis. Okay, so let's draw the diagram first, then we will fill up this data. Okay, so considering this is the parabola whose equation is y minus beta whole square is equal to 4a into x minus of alpha. So the parabola look concave at the right hand side. Okay, and this is the line which symmetrically divide the curve. So that is why this is the axis of the parabola. So this is the axis. Okay. Now this axis is not x-axis because this vertex, you can say this is v, which is at alpha comma beta. Okay. So vertex is at alpha comma beta. So first of all, we should write vertex is at v, which is alpha comma beta. Now this axis of the parabola is parallel to x-axis. So considering this is x-axis, okay, and this is y-axis. So this is the origin. Clear? So axis is parallel to x-axis and passing through the point alpha comma beta. So equation of the axis should be is equal to y equal to beta. Okay. So what is the equation of the axis? So equation of the axis is y equal to beta. Understand? Clear? Now definitely focus has a distance a unit from the vertex, and we know focus always lies on the axis of the parabola. So we can consider this is the focus and it has distance a unit from the vertex. Clear? So what will be the coordinate of the focus? Definitely focus has x coordinate alpha plus of a and focus has y coordinate beta. Okay, clear? So we should write focus S has coordinate alpha plus of a comma beta, and you should know that length of the lattice rectum here again L1 L2 is equal to 4 into a. So y minus beta whole square is equal to 4a into x minus alpha has same lattice rectum is equal to L1 L2 having length 4a. So this is L1 L2 and SL2 is 2a, SL1 is also equal to 2a. Understand? Clear? So y square is equal to 4ax and y minus beta whole square is equal to 4a into x minus alpha has same lattice rectum length, and length of lattice rectum for each cases of the parabola y square is equal to 4x and y minus beta whole square is equal to 4a into x minus alpha equal to 4a. That is length of semi-lattice rectums are 2a. Okay. Now definitely this is the directrix which lies at the exterior region of the parabola. So this is the interior region, is it? This is the interior region and this is the exterior region. Okay, exterior region. Now we should draw the directrix which is perpendicular to the axis of the parabola, and directrix has distance a unit from the vertex. So this is the point D. This distance from the vertex is equal to a, and directrix is the line which is perpendicular to the axis of the parabola. Got it? Clear? So this is the directrix. What is the coordinate of the point D? The coordinate of the point D will be definitely alpha minus of a comma beta. Okay. So as the directrix is parallel to y-axis and passing through the point alpha minus a comma beta, so what is the equation of the directrix? Definitely its equation will be x is equal to alpha minus a. So equation of the directrix can be written as x is equal to alpha minus a. Understand? Clear? So we should write directrix is x is equal to alpha minus a. So directrix is parallel to y-axis and passing through the point alpha minus a comma beta. That is why equation of directrix is x is equal to alpha minus a. If we assume any point P on this parabola whose coordinate is x comma y, P is the moving point, then according to the definition of the parabola, this PS should be is equal to Pn. Okay. So that is why here also PS is equal to Pn. Okay. So what we learned? We learned y minus beta whole square is equal to 4a into x minus alpha is a parabola. It's concave at right hand side. The vertex of this parabola is at alpha comma beta. The coordinate of the focus of the parabola is alpha plus a comma beta. The length of the lattice rectum is equal to 4a. The axis of this parabola is parallel to x-axis whose equation should be is equal to y equal to beta. The directrix of this parabola is parallel to y-axis whose equation should be is equal to x is equal to alpha minus a. Okay, clear? And if p is any variable point on this parabola, then ps should be is equal to pn according to the definition of the parabola. Understand? Clear? Now come to the another form of the parabola, that is if the parabola is of the form of y is equal to ax square plus bx plus of c, then how we can identify the parabola? Okay, so let's have a look. So friends, now we are discussing the parabola is of the form of y is equal to ax square plus bx plus c. And this form of parabola is very important to study the quadratic equation ax square plus bx plus c is equal to 0. Okay, so here we will discuss the different form of the parabola y is equal to ax square plus bx plus c. And you must remember here a should not be is equal to 0, because if a is equal to 0, then this equation will be a linear equation, nothing else, is it? So that is why here a is not equal to 0. So as a is not equal to 0, so a may be positive or a may be negative. Now if a is positive, then this parabola y is equal to ax square plus bx plus c is concave upwards. And if a is negative, then the parabola y is equal to ax square plus bx plus c is concave downwards. So depends on the value of a, y is equal to x square plus bx plus c must have 6 diagram. Look what are the diagram. So we draw here 3 parabola and all of this parabola are concave upward has equation y is equal to ax square plus bx plus c. So this parabola has also equation y is equal to ax square plus bx plus c, and this parabola has also equation y is equal to ax square plus bx plus c. And all of these three cases, the value of a is greater than 0. Okay, clear? So when a is greater than 0, then the parabola is concave upwards. Now, it may be that this parabola neither touch nor cut the x-axis. Okay, clear? Or the parabola may just touch the x-axis. And in this case, the third case, the parabola may cut the x-axis at two distinct points. Okay, clear? Now look, the vertices. So this is the vertex. In this case, this will be the vertex. In this case, this will be the vertex. Okay? In each of these three cases, the coordinate of the vertex of the parabola will be minus b by 2a, comma, minus d by 4a. Okay? Where the value of d is equal to, b square minus 4ac. Okay, so what is the value of d? The value of d is equal to b square minus 4ac. So here also the coordinate of the vertex is minus b by 2a, comma, minus d by 4a. Here also the vertex is minus b by 2a, comma, minus d by 4a. Understand? Clear? Now, under which condition the parabola neither cut or not touch the x-axis? Here the condition is the discriminant of this ax square plus bx plus c, that is b square minus 4ac, should be less than 0. In this case, the discriminant should be is equal to 0, and in this case, the discriminant should be greater than 0. Okay, clear? So when a is greater than 0 and d is less than 0, then the parabola y is equal to ax square plus bx plus c is concave upwards and neither touch nor cut the x-axis. When a is greater than 0 and d is equal to 0, then the parabola y is equal to ax square plus bx plus c is concave upward and just touch the x-axis. When a is greater than 0 and d is also greater than 0, then the parabola y is equal to ax square plus bx plus c cut the x-axis at two distinct points and it is concave upwards. Okay. Similarly, when a is less than 0, then the parabola will be concave downwards. And in this case also, we have three different cases. So, maybe like this. So we draw three parabola in three different cases which are all y is equal to ax square plus bx plus c. Okay. So this is also y is equal to ax square plus bx plus c. So look, I draw three parabola which all are concave in downwards. In the first case, the parabola neither touch nor cut the x-axis. In the second case, just touch the x-axis, and in the third case, it is cut the x-axis at two distinct points. Okay. Now, in these cases, or in all of these three cases, the value of a is less than 0. Okay. So when a less than 0, then the parabola concave downwards, and when a greater than 0, the parabola concave upwards. Okay, and the vertices, that is vertex of this parabola or this parabola or this parabola, have coordinate minus b by 2a comma minus d by 4a. The value of d is definitely b square minus 4ac. So here also the vertex is minus b by 2a comma minus d by 4a. Okay, here also the vertex is at minus b by 2a comma minus d by 4a. Okay, clear? And the condition that the parabola neither touch nor cut the x-axis, that is the whole parabola below the x-axis, is when d is less than 0. The condition that the parabola just touch the x-axis, in that case it is d is equal to 0. And when d is greater than 0, then the parabola cut the x-axis at two real and distinct points. Okay, so these are 6 diagrams of the parabola y is equal to ax square plus bx plus c, depending on the values of a, b and c. Okay, and you must remember here a should not be equal to 0. A either greater than 0. For this we have 3 cases, depends on the value of the discriminant, that is d. And when a is less than 0, then we get the 3 cases, depends on the value of d. Understand? Clear? Okay, now come to the next concept on parabola. Let's have a look. So friends, now we are discussing the parametric equation of the parabola. Okay, you know very well, if in any equation of x and y, if the variable x and y depends on the third variable, suppose the third variable is t, then this third variable is known as the parameter of the given curve. And the relational equation x with t and y with t togetherly represents the parametric equations of the corresponding curve. Okay, so look, the parametric equation of the parabola y square is equal to 4ax is x is equal to 8t square and y is equal to 2at. So these two equations togetherly represents the parametric equation of the parabola y square is equal to 4ax. Okay, so here t is the parameter, and all we know that x comma y is any variable point on the parabola. So that is why geometrically we can say, geometrically 80 square comma 280, that is x is equal to 80 square, y is equal to 280. So x comma y means 80 square comma 280 is any variable point on the parabola y square is equal to 4ax. Okay, so this pair of equation x is equal to 80 square and y is equal to 280 togetherly represent the parametric equation of parabola y square is equal to 4ax, where t is the parameter, t is the third variable. Both x and y depends on the third variable t. A is constant. Okay, and geometrically 80 square comma 280 is any variable point on this parabola. Okay, now look, what are the pair of parametric equations of other parabolas? Okay, so better we'll write here the curve, suppose y square is equal to minus 4x or x square is equal to 4ay or x square is equal to minus 4ay, or you can say y minus beta whole square is equal to 4a into x minus alpha. So if we want to find the parametric equation, pair of parametric equation of these curves, so parametric equations. Okay, so For the equation y square is equal to minus 4x, the set of parametric equation is x is equal to minus 80 square and y is equal to 280. Okay? Clear? For the equation x square is equal to 4ay, for this parabola, the pair of equation x is equal to 280 and y is equal to 80 square is the pair of parametric equations of the parabola x square is equal to 4ay. Okay? So if we substitute y by 80 square and x by 280, then both sides will be equal for the equation x square is equal to 4ay. Same for y square is equal to minus 4x, same for y square is equal to 4x. Okay? Now come to the parabola x square is equal to minus 4ay. So here the pair of equation x is equal to 280 and y is equal to minus 80 square togetherly represents the parametric equations of x square is equal to minus 4ay. Okay. Now come to the parabola y minus beta whole square is equal to 4a into x minus of alpha. Here x minus alpha is equal to 80 square and y minus beta is equal to 280 togetherly represents the parametric equation of the parabola y minus beta whole square is equal to 4a into x minus alpha. So geometrically minus 80 square comma 280 is any variable point on the parabola y square is equal to minus 4x. 280 comma 80 square is any variable point on the parabola x square is equal to 4ay. 280 comma minus 80 square is any variable point on the parabola x square is equal to minus 4ay, and alpha plus 80 square comma beta plus 280 is any variable point on the parabola y minus beta whole square is equal to 4a into x minus alpha. Understand? Clear? So this is the discussions on the parametric equations of the parabola, and all of these 5 concepts belongs to your syllabus. So please remember this, very important for the discussions of various properties of parabola or numericals in easy way. We use this type of parametric equations. Okay, clear? Now come to the next concept. So friends, now we are discussing the position of a point with respect to a given hyperbola. That is, if the given point is P whose coordinate is x1, y1, whether it is lies outside or on the parabola or inside the given parabola. So for example, the given parabola is y square is equal to 4ax. Okay, so the point P x1, y1 lies outside of the parabola y square is equal to 4ax if the condition y1 square minus 4ax1 is greater than 0. So this is our first concept. The point P x1, y1 lies outside of the parabola y square is equal to 4ax if and only if y1 square minus 4ax1 is greater than 0. Okay, clear? So this is the first concept. The second concept is, if the point lies on the parabola, then the equation of the parabola must be satisfied by this point, is it? So the point P, that is x1, y1, lies on the parabola y square is equal to 4ax. The condition in this case is if y1 square minus 4ax1 is equal to 0. Okay. So the point lies outside the parabola y square is equal to 4x. If y1 square minus 4x1 is positive, the point P x1 y1 lies on the parabola y square is equal to 4x when y1 square minus 4x1 is equal to 0, and the point P x1 y1 lies inside the parabola, that is lies at the interior region of the parabola when y1 square minus 4x1 is negative. Okay, so please write down the next statement. The point P, that is x1 comma y1, lies inside of the parabola y square is equal to 4x, that is lies at the interior region of the parabola y square is equal to 4x if and only if y1 square minus 4ax1 is less than 0. Okay, clear? So these are three important conditions, very important conditions for your numericals. So please remember these three conditions. Although these conditions are very easy but important for your numericals. So similarly, if the parabola is x square is equal to 4ay, then the point P x1 y1 lies outside of the parabola when x1 square minus 4a y1 is greater than 0, lies on the parabola when x1 square minus 4a y1 is equal to 0, lies inside the parabola when x1 square minus 4a y1 is less than 0. Okay, if the curve is s is equal to 0, that is the parabola is s is equal to 0 and x1 comma y1 is any point, then the positions of this point P with respect to this parabola s is equal to 0 is when s1 is greater than 0, then the point P lies outside the parabola. When s1 is equal to 0, then the point P lies on the parabola, and when s1 is less than 0, then the point P lies inside of the parabola. Okay, I think you remember. Now come to the next concept of the parabola. Let's have a look.